Hey, I'm still talking about a parabola, chapter 10. You know, the definition of a parabola, the geometric definition of a parabola, I really like this. It says, here it is, I wrote it down, it's the set of points, x, y, that are equidistant from a fixed line, called the directrix, and a fixed point, called the focus. It's not on the line. You can't have this point on that line. That wouldn't work. It's the set of points that are equidistant, the same distance, from a fixed line called the directrix and a fixed point called the focus. So you could build yourself one of these. You could go out in the grass and do this, or I can do it right here and watch. And what I need is a line. So here's a line. Oops. So that'll be my directrix. And then I just need a point that's not on that line. There it is. There's a point not on the line. That'll be my focus. This is my directrix. And then the parabola consists of all the points that are equidistant from there, from the point and the line. So the first point that's equidistant that you could, is this guy right in the middle here, which happens to be the vertex. And that distance happens to be p. So that distance p and that distance we call p. Anyway, that's the first point that you could say is on the parabola. But look, all I need is that distance to be the same as that distance, this perpendicular drop down distance. That distance to be the same as that distance. That distance to be the same as that distance. And then this set of points forms the parabola. The distance, the set of points whose distance to the focus is equidistant to the line, the directrix. And that set of points geometrically forms a parabola. So you could get out in your yard and make one of these. Or like I just did here. I mean, I could have done a little better job with some measuring and some string and some, but there you go. Now, let's talk more about, here's one of the things that happens with a parabola is it's got this reflective property in physics. And so any incoming light rays hit this parabola and they bounce to the focus. Now, wait a minute, not any incoming light rays. Incoming light rays that are perpendicular to the directrix. So these light rays that come in like this. I guess a light ray like this will bounce somewhere, but it won't necessarily bounce to the focus. So when they come in perpendicular to the directrix, they have this reflective property where they bounce to the focus. This angle matches this angle perhaps, and they bounce to the focus. So that's why, the satellite receivers mount the receiver at the focus. Satellite receivers are shaped like a parabola, and then they mount the actual receiver of the signals at the focus. And so all this ESPN comes in here, bounces to the focus. Fox News comes in here, bounces to, see, anyway, yeah. History Channel. Cool. If maybe you wanted to, you could build a parabolic reflector. You could put you wanted to cook some food or something like that. All the incoming heat from the sun would bounce to this point. And so maybe you could make a little parabolic oven. I don't know. It works in reverse too. They put a parabolic reflector behind a flashlight or behind the light of a flashlight. So like if this was the light bulb of the flashlight, here goes the light going out, light's going out. But any light that goes out this way hits the parabolic reflector and gets bounced out this way. So the flashlight can focus its light outward. So it works on incoming light or outgoing rays from the focus. So there's a lot of cameras, lenses. There's a lot of applications for this parabola and for finding the focus.